This is a picture of Wynn Las Vegas. It's a nice hotel in Vegas on the Strip. And if you wanted to go there for this weekend, you would have to pay $349 a night. That would be for a Friday night and a Saturday night stay. You'd pay $349 each, plus taxes, plus resort fees. However, if you are willing to postpone your trip and go there and stay there on a Monday and a Tuesday night instead, the hotel rate goes down to $125 a night. So, how would this company know to fix their prices where it's $349 a night if you go for a weekend stay, but it can go down to $125 if you go for a weeknight stay, and still make sure that they don't lose money? How these companies do it is by studying their cost behavior. So, what is cost behavior? Cost behavior is the study of how costs change as volume changes. We're going to look at three common types of cost behaviors. First one's variable cost, the next one's fixed cost, and the third one is mixed costs. First, let's look at the key characteristics of variable costs. Variable costs are costs that change in direct proportion to changes in volume. So total variable costs change in direct proportion to changes in volume. The variable cost per unit remains the same, and the slope of the cost graph is the variable cost per unit. We'll explain that in a little bit. And you could also express variable cost in the form of an equation. In your equation, you would be depicting y as your total variable cost, and it's equal to variable cost per unit of activity multiplied by volume of activity, or y equals Vx. Let's take a look in more detail at what each of these things mean. Let's take a look at an example. Let's assume that you went to buy gas. A regular is $3.50 per gallon, and let's see how the cost of gas behaves with changes in volume. Let's say you buy 1 gallon of gas. You would have to pay $3.50. How about if you buy 2 gallons of gas? You would have to pay $7. How about if you buy $4 of gas? You'll have to pay $14. And if you buy 10 gallons of gas, you'll have to pay $35. We can say that gas is a variable cost. It varies in direct proportion to changes in volume. We can write a cost equation for our variable cost. We can say y equals Vx, where y is your cost, it's your total cost. V represents your cost per gallon, and x represents your volume. So if you wanted to find your volume or your total cost, which is y, at 20 gallons, you would say y equals V, which is $3.50, times x, which is 20. And you would end up with $70. So y would equal $70. Let's take a look at some cost graphs for variable costs. Whenever you're looking at cost graphs, your vertical axis, which is your y-axis, always shows your total cost. This is the y-axis. The vertical axis, which is the y-axis, always shows your total costs. Your x-axis, which is your horizontal axis, always shows your volume of activity, so total cost and volume of activity. Let's take a look at our graph for purchasing gas. In our graph, you will have costs in your y-axis and volume of gas purchased in your x-axis. Let's plot the numbers, and we find that if we didn't purchase any gas, so if our volume is 0, you know that that is 1 point on your graph. You also know that if you buy 10 gallons, your cost is 35, so your second point is about there. And direct costs are, or variable costs are directly proportional to changes in volume, so it's a linear relationship, so we can draw a straight line between these 2 points to show our variable cost graph. And this is what it would look like. it would look a lot straighter if you had better drawing capabilities than me, but that's what it would look like. This is your total cost line, and now that you have this, you can calculate your slope. The slope is a change in cost divided by change in volume, and that equals the variable cost per unit. And as you remember, our variable cost per unit for this particular graph was our cost per gallon of gas, which was $3.50. So to summarize, the variable cost line always starts at the origin. It's a straight line, and the slope of the line is equal to your variable cost per unit.